Well, good morning. This is May 10th, and they're getting ready to pour concrete, so I haven't got to do much with the construction build today. Thought we would go over small parts. You get these photo panels, PV solar panels on order, and you got to line up on a inverter. You kind of figure what batteries you're going to be able to afford. And then it occurs to you got to connect all this stuff together. And there's a lot more bits and pieces goes in there than just those three major components. I know you see people that string wires across the tabletop and a bunch of loose pieces piled up. But if you're going to have this as your only source of electricity, you got to be able to maintain it, and it's got to be where it won't self-destruct. So we're going to look at some of these smaller parts. Now you can take and run number 4, even sometimes number 6 cables back and forth, and crimp on some connectors on the end, ring connectors, lugs. But rather than just trying to get all your leads the same length, and there's some other considerations, it's just so helter-skelter running around there. And you have a lot of things that are open electricity that your dog, your cat, your children, your quail cage gets open and you have 200 birds in there all of a sudden. Well, that could get messy. So what we're going to do on this case is we're going to put 2 pieces of 1.5 inch by 1/4 inch angle iron down the wall, one for positive, one for negative. Now these things have to be electrically isolated, otherwise they would short to each other or short to the wall or whatever. So the little red doobers we're looking at here, these are voltage isolators. They're called low voltage because they're like rated 1200 volts or less. High voltage is like 33,000 volts, 100,000 volts. These ones here, let's see. The biggest ones are 50 cents. The size we ordered is 42 cents. The one I'm pointing at here on the left, that's what we ordered. To get the price on the shipping, we bought 150 of them. Need about 60. But if I wanted to buy 60, it would have cost me more. And I've had different things I wanted to use these on, so I don't mind buying a few extra. And they're shipping right to the door, so that's nice. Let's go back to Alibaba here and see who's next on the list. Let's see this one here. Need more of a close-up than that. Well, what we're looking at here is heat shrink tubing. If you're going to buy heat shrink tubing, you better buy the better kind. If you're trying to get to a pretty decent product quickly, look for dual layer, adhesive lined, and that'll get you there. You want to cross-link the polyolefin for the material, and if you specify marine heat shrink tubing, it's pretty much every bit of it is this stuff right here. Now, we didn't, this company makes it in colors, but we have different color wires, and I didn't want to get involved in having to buy a full roll of each size and each color. So if I have all black, I'll mark them some other way. I can put, you can get multicolored vinyl electrical tape all over the place in the Philippines, about 6 color, all the primary colors. So you can put a wrap around that to keep them separated. This is a product speak. Cross-link polyolefin rake hem heat shrink tube, certification ROHS and Underwriters Laboratory. This one's 600 volt in black. Shrink ratio. When you get the one that shrinks 3 to 1, like if it's 3/4, it'll shrink down to 1/4. What that does for you is the wall thickness goes up by 3, because there's the same amount of material there. It shrinks mostly in the width, only like 3% in length, but it shrinks all of the width. So when you get a double wall with adhesive, 3 to 1 is about the go-to size. You can get 4 to 1 without adhesive. It'll shrink to 1/4 its size. Another picture here. They're showing you how much it shrinks down, and that the glue squirts out down here when you heat this stuff. As soon as you see the least little bit of glue getting shiny or bubbly around the ends, quit heating. It will tighten right up. You don't have to heat it anymore. In fact, it'll make it uglier if you keep on heating it. And they're telling you there's thick wall after it shrinks. Cross-length polyolefin. Whoever here is, they decided to buy it in a bunch of different colors. And if you have 3 or 4 wires the same size, you have to buy you can buy it in short pieces, in kits. Here's a kit. This has got different sizes, 1, 2, 3, 4, 8 sizes and multiple colors. You can have your name or logo put on it. It's not very expensive. Okay. Here we go. So, on the left is the diameter, inside diameter in millimeters. Remember, there's 25.4 millimeters in an inch. So 12 is a little less than half an inch. Starts out half inch. It'll go down to 4 millimeters. That's like 3/16 of an inch. Gives you what the inside and the outside and all those diameters, and wall thickness and adhesive thickness, meters per piece if you bought it in pieces. If you bought it in a spool, I bought it in spools. This 4.8/1.5, that's for all the receptacles and outlets in the house. I got 292 light bulbs, and 178 receptacles, plus switches. I don't know how many of those there are. Not very many, maybe less than 50. Because there's a lot of them turn on multiple lights, the 3- and 4-way switches. But that comes on 100 meters through the spool. If you're using about 1.25 inches on those forked connectors, one spool would have been plain. But once you're going to buy this stuff, you have to pay shipping. The shipping is going to be a third the cost of the product. So I decided I'm just going to buy me a lifetime supply just while I was at it. So I doubled up on that. And then the 19.6, it's only 25 meters to the spool. And that's your number 4 AWG4. And that's all the batteries and stuff in the electrical room. So 25 meters might have been a little tight on that because the connectors are deep tube DTs. They're about twice as much crimp area and solder area, and the tabs are pretty thick. But anyway, it's going to take a longer piece of that. So I got 2 spools of that. The cost per spool is about the same on every one of them because the length on the spool changes. We got some 9-3. I forget what that's for. Comes 50 to the spool, and that was plenty. I only needed like 10 meters. The spool got 50. Okay. Heat shrink tubing. If you're in a salty, wet, high humidity environment and you're fighting rust and corrosion gets up under the insulation of your wires and makes them non-conductive, which is a real bitch when you have excavators and a bulldozer with big heavy cables strung all through everything, and the electric won't come out the other end to crank it. You got 1,300 amps of batteries, and the motor won't turn. It's like they're dead. That's a little rant from days gone by. Who we got here? Oh, these were good people. Nice people to deal with. A really solid product. This is some of their models. This is Heltec BMS. I looked at pre-made batteries. They're around about $2,400 for one battery pack, LiPo. That'd be 48 volt, 200 amp hour cells. But I can get 280, 300, 320, and 380. They cost more than the 200 amp cells, but not that much more, for a lot more capacity. The second thing is you can get cells that have been cycled around 2,000 to 3,000 times on a 6,000 cycle life. You're not going to be running them full cycle like they did the first few cycles. They're used in like public buses, those big interprovincial buses in the Philippines that have to go in the city. They might be electric. Chinese buses are invariably electric. A lot of the Asian countries don't allow a diesel in their cities. They got pollution problems, so they just don't allow it. Okay, we're looking at two right here side by side that are probably both. The left one's 250. Right, they're both 250 amp. They're both 3.2 volt batteries. The difference here is split port on the left and same port on the right. If you've got separate charge controllers and a separate inverter and batteries, you're probably going to get the split output type. If your battery cables come from your inverter to your batteries, or to your BMS to your batteries, and the same power goes back through the cables when you invert it. The electric's either coming to the batteries or going away. Then you get same port, because you haven't got those other two wires. I hope that makes sense. The rest of the thing is pretty much the same. You see at the top you have plugins for, I can't think of the name of them. Mazda sells them, all those people. What do you call those plugins? Anyway, they got like 17 pins on these ones. That's because you have a wire from for your battery negative, and then you have a wire for every positive lead on a battery. 48 volt, 16 cells. You know, 3 times 16 is 48. It's actually 52 because the batteries aren't 3.2. Okay. You can have this in smaller things. This next one over 165 amps and a 60 amp. And you'll notice that this Heltec brand, unlike virtually every other brand of BMS that they sold, there are no heavy wires coming off the circuit board. It's not because they're cheap. They don't want you soldering on a circuit board with a whole bunch of MOSFETs and other electronic components right next to where you're soldering. To heat up that big bar of copper takes an awful lot of energy. You can get a piece of like 1.25 inch flat bar, heat it up with a acetylene torch, and then when you get your wire and your soldering stuff ready, just set it on that bar. It'll instantly come to temperature, and you can solder it pretty quick, a few seconds. If you try to heat that thing up with an electric soldering iron, you probably wreck the board. You'll definitely void the warranty. And plus, the holes in the board are not small enough to carry the size of bolt it takes for a cable lug. So what they did was they made it where you bolt your terminal lugs to the copper. You through bolt it. You can put one on either side. As long as you've got a good contact patch. I don't know if we're going to find that I've ordered those on today's thing, but I got them with 2 holes on the end. And I can put it on the upper 2 holes on one side and the lower 2 holes on the other side, and whatever. We also bought from these people active balancers. An active balancer, rather than when BMS sees that one cell is getting to the stop charging place, it cuts off charging. It takes that high cell and runs it through a resistor and burns it off as heat. And when it gets to the threshold, then it starts charging again. And you keep just bumping them up until you get all of them pretty close to the high mark. And when you get within this range where it doesn't ever drop down enough to start the charger again, then it goes on to passive balancing. And two adjacent cells can transfer electric, a really small, like 0.6 of an amp current. But it can't transfer it from the one that's the highest in the pack to one that's 8 cells away. It's got to load share bits and pieces, one to the next, one to the next, one to the next. It takes forever. If you ever get it balanced, it will pretty much stay that way. But initially, even if you charge them all to the same, that makes it called top balance. If you charge them all the same before you put the bus bars across them, that'll work. But these people make an active BMS, or active balancer. There are several companies that make active balancers. They run completely independent of the BMS. They run whether the power on the battery is on or off, does not make a difference. They take the highest one in the pack and put it into the lowest one in the pack. And they do that by charging the supercapacitor. That's a flat plate capacitor like you use to run big electric cars on. Not the Tesla's little 18650, 100,000 in a pack. You have these big flat plate capacitors that you can drive halfway across the United States on one of them. They're terribly expensive. Anyway, it charges this fancy capacitor, and it can take a considerable amount of electricity of top charge away and put it to the lowest one in the bunch. And another advantage, because it's independent, you can have more than one of them. So I ordered extra wiring clips and harnesses, and I ordered my terminal blocks with 4 connections to each terminal block, so I can have the leads to the battery, the BMS to the terminal block, and 2 active balancers, one installed and one of them in case I put in a really crappy battery in there and don't want to dismantle everything or somehow bring that one up pretty close. I can stick a second active balancer on there and knock it out overnight. Anyway, that was the next thing on the list was you have to have either you buy battery packs and paying about $600 more per pack, or you buy the highest quality grade A plus cells and a BMS, and they come with all the straps that connect them together. You want to buy them with the tin-plated copper straps, not aluminum straps, not steel that's cadmium plated. It's got to be solid copper, and it needs to be tin-plated. Tin for corrosion resistance, plus it conducts better. Some materials are surface conductors and some are through-body conductors. Tin coating, I think, is a surface conductor, because if you buy a number 2 welding cable, say you buy number, just a AWG2. It's rated like 195 amps as a copper cable. If it's tinned copper, it's rated 580 amps. Same diameter conductor core, but the wires are very fine and they're conducting through the tin on the outside. So, and plus the tin is in contact with the copper, so if the copper is a through-body conductor, it's also conducting. But you're picking up that surface area on the tin is what really makes them rated high. And plus they don't corrode. And the finer wires are more flexible. It's easier to roll them up and unroll them, and it doesn't cost that much more, really. Okay, we're going to stop here at the BMSs because I'm showing 19 minutes, and that's past my attention span and probably other people's. And we're going to pick it up with the next item on the list, and I don't know what that is right this minute. But we're going to stop this, and then we're going to come back.